the body as we do from the face. So body is everything from the spinal cord. Face is going to enter through other parts of the brainstem, not the spinal cord. Our spinal cord, so the body pathways only go up through part of the scalp. The rest of the face is going to be from cranial nerves, particularly cranial nerve 5, right? 5 does general sensory. So this will be, yeah, we'll talk about that over here. Okay, let's start with body. Actually, let's look at generalities. Let's start with the big picture. Where are all these going? What's the termination of both of these pathways, or all of them?
In the birthday.
3, 1, 2. All of the stuff we wrote over there. So it's all going to 3, 1, 2. The third is going to be some thalamic nuclei. For the body, it's always VPL. For the face, it's always VPN. Don't even try to learn that. It's like ventro, postero, lateral. It's like too many directions that don't make sense. So VPL, VPM. I know the L means lateral, so I always like pictures hold my arms out. My hands are lateral to my face. All right, my face is midline, my hands are lateral. And so this is VPL, VPM, the medial and lateral. Okay, everything that is a commonality, I'm going to write in black, and then I'm going to use colors for other stuff. Body, the primary neuron is always the dorsal root ganglion. For face, it's usually trigeminal ganglion. I'm going to put an asterisk here. It's only true 2 out of 3 times, and you may even want to get more specific. So whenever I put that, it means that there's could be exceptions. All right, and then the last piece. The only thing you need to know really at this part for these pathways is what's the second one, right? Because we know for the body pathways, we know it's always going to start in the dorsal root ganglion. The third's going to be the VPL. It's going to end up in 3, 1, 2. So for the DCML and the spinal thalamic, all we need to know is where that second one is. But we do know something about the secondary neuron. For all these pathways, it's always the same. This is always where you have the decusation. So if you know where that secondary neuron is, if it's in the spinal cord or the medulla, you know where it's decussating. Is it decussating right away in the spinal cord or later on in the medulla? You know that based on where that secondary neuron is. Okay, DCML. Those are going to be the nuclei. Do you remember what they are?
Cutaneous and
Close. Cuneatus and gracilis. Cuneatus is upper extremity, so above T7. Gracilis, we have gracilis muscle, so it's lower extremity, below T7. So each one of those, so you'll have within the DCML, DCML is actually broken into 2 segments. Fasciculus cuneatus and fasciculus gracilis. Where do you think fasciculus cuneatus goes to? Nucleus gracilis? No. Nucleus cuneatus, right? So the name goes to the same name of the nucleus.
Oh, yeah.
So those axons will go into these nuclei, and they're going to synapse here. Fasciculus gracilis goes to nucleus gracilis. Fasciculus cuneatus goes to the nucleus cuneatus. And then these do some weird stuff. They start to, like a ribbon, they kind of rotate as they go up.
And are they above the medulla for the motor? Because he made a point of that, of which one's
Like
does
open
hit
versus
first. Is it motor and then it's
I'm pretty sure, yeah, actually I forgot that
No,
part.
it's in our notes.
Yeah. Yeah, that's a detail that once you get this, then you can add that detail on fairly easily. But I think it helps to kind of first have a strong foothold on the rest of this stuff. But yeah, I forgot about that. But it's, the lemniscus means ribbon, and it just rolls up. Where's the spinal thalamic? Where's that secondary neuron?
Yeah.
3 and 4. Laminae 3 and 4 in the spinal cord. Within 3 to 4 levels of entry. So if it's entering at L4 by L1, it's going to be on the other side. That's exactly what we covered over there. So this spinal cord, this is medulla. So that's how we got Brown-Séquard. The secondary neuron for DCML is in the medulla, and that's where it decussated. Secondary neuron in spinal thalamic was in the lamina 3 and 4 in the spinal cord, very close to where it enters, and that's where it decussates. So this will help you know where the decussation is. Also holds true for the face pathways. If you know where that secondary neuron is, you know where it decussates. Now, I don't think I was taught this, but I just noticed the pattern. All of them seem to decussate, so I made up my own rule. With neuro, it is important to look for patterns. Look for patterns, chunk things together, and then try to understand why, but sometimes it's just that's the way it is. And if it's just the way it is, then you come up with a silly, made-up story that helps you remember it. Okay. Anything else? So just let me say real quick, upper motor neuron versus lower motor neuron lesions. I think this is very important. Remember, this is spastic. This is flaccid. So everything here is hyperactive, everything here is hypoactive. Because with an upper motor neuron lesion, you still have the lower motor neuron working in supplying that muscle. Okay, so upper motor neuron lesions, we have spastic, so it's a spastic paralysis. Reflexes, hyper, reflexia. Muscle tone, increased muscle tone or decreased?
Increased.
Increased. It's like the patient who had his muscles in his forearm were so tight he had to get Botox shots. Hypertonia. Oh, we already talked about this, the spastic paralysis. Babinski reflex. Positive Babinski.
Is that the toes going upward? Or not? Nothing?
That's the fanning out upward, yeah. Yeah, it's the weird, it's the way babies respond with their reflex. And then what about atrophy and fasciculations?
Yep.
Negative atrophy. I'm pretty sure fasciculations are there too. I get confused by that. With underuse, eventually, you will get muscle loss, but it's more pronounced if it's a lower motor neuron issue. Because the lower motor neurons, they feed nutrients and growth stimulators to the muscles. And so if you cut this off, you're going to get more pronounced atrophy. But with this, that's not working, but the lower motor neuron is. I'm pretty sure fasciculations are also positive for lower motor neuron, but I'm not 100% positive. Okay, hyporeflexia. hyporeflexia, hypotonia, flaccid paralysis, negative Babinski. What if you're normal and you don't have any motor lesions? What's your Babinski going to be like? Negative Babinski. Yeah. So this is a normal state to be negative if you're an adult. This is normal. If you have positive, then that's abnormal. It's signs of an upper motor neuron lesion. And so if you have signs of an upper motor neuron lesion, what part of the body are you thinking about? Brain, what else? So cerebrum, maybe frontal cortex, maybe internal capsule, maybe crus cerebri, maybe medullary pyramids, maybe spinal cord, right? All the places where it's going. That's what you're thinking to this. You're not thinking about dorsal root ganglion. That'd be the wrong function anyway. All right, so separate in your brain these things and start thinking, this is like a nerve, like a pinched nerve or something. That can lead to lower motor neuron issues, or if someone has a stenosis that affects the spinal nerves as they leave, that can be a lower motor neuron issue. Hyporeflexia is like a 0, maybe +1. Hyperreflexia is a +3, +4. Sometimes they give you that. +2 is normal. That's why +2 is normal, because too much is not good either. Another thing that happens with upper motor neurons is, so it's very spastic, right? And because it lacks modulation from the brain. And so a patient that has upper motor neuron lesions, Brown Séquard, I remember one time she wanted acupuncture, and so I was taking off her shoe, and when I did that, her foot just started doing this. It's called clonus. And so what I had to do, I didn't know what to do, and she just put firm pressure down on my knee, and it'll go away. So that kind of firm pressure, for whatever reason, it would kind of slow it down, and then it went back to normal. It's something about it, maybe there's kind of reflex pathways or something, but that's called clonus. You can watch pictures of it, but clonus will happen when you move the limb too fast. So you move the limb, and then the muscles try to respond, and then they try to respond again, and it's just kind of do this. I think that's how it works. So just firm, steady pressure on the knee, just kind of pushing your leg down and her foot, and just kind of. But hopefully you're getting the picture of upper motor neuron, very hyperactive, very spastic. This picture should be clear, this picture versus that picture. And if it's not clear, just watch some YouTube videos. Watch spastic paralysis and hyperreflex and all that. Yes?
So, when we learned about the cerebellum, we talked about like a pendulum reflex. Is that what clonus is? Like when you hit the major, so instead of it jerking just one time, it just goes back and forth once you hit that thing. Like it doesn't stop. And that's a cerebellar issue.
That's a cerebellar issue. Anything else?
As far as gross anatomy goes of just structures in the brain and such, is that something that we should be focusing on? Because for my presentation, we did reticular formation and limbic system, and then part of it was and part of it we just went through the anatomy, where is everything in relation to everything else. Is that important for
I think it's good to know where things are in general. Start with general locations. So if it's cerebrum, what lobe is it? Start very broad. If it's brainstem, what is it? Midbrain? Is it pons? Is it medulla? Start there. Then you can get a little more detailed. But if you look at the, do you have the Weigert slides? Okay, so the way we learned was we learned all the cross sections too, and so which was actually, don't envy me that I got to learn these. It was very difficult. So for each level, 4 more in the medulla, multiple in the pons, we'd have to locate all the different nuclei, what's there, what's leaving, what's coming in, nuclei and tracts. Now that was very useful, and I learned it kind of more particularly based on cranial nerves and then those 3 pathways. I need to know where those were located at every level. And then everything else kind of starts to make sense. If you know cranial nerves in general, you should know cranial nerve 5 is gonna be higher than cranial nerve 11. 11 is gonna be kind of lower medulla, upper cervical. 5 is gonna be up in the pons area. Although there's some disagreements on 5. But I think there is use to that. But I think it's overwhelming to try to learn all of the structures all at once. And so I try to learn in pathways. And so if you pick one pathway, like corticospinal, and you know every level, internal capsule, crucicerebral, all those things, you follow it as it goes, that's how you're gonna learn where these things are. You learn that one, and then you'll learn another one, and then before you know like 5, and it's really good, actually.
Okay.
With that question, let me show you one thing. Very simple, you never can leave here.
Is he saying that?
Cranial nerves, where they exit the central nervous system or enter, depending on the way the peripheral central, let's go 1 and 2. Go right into the cerebrum. Right, optic and olfactory, right into the brain. 3 and 4, midbrain. So these are where the most of the nuclei are. 5 and 6, pons. Now keep in mind some sources, I think say 6 is more pons medulla. I'm going to give you one way, but keep in mind this is not the only way. But this is the way that is the simplest. 7, 8 is at the pons medulla junction. And then the rest is medulla. This is important because like cranial nerves 7 and 8, they're close together. And so an acoustic neuroma, where you have a tumor of 7, can lead to issues with 8 because they're physically close together. And so that's where the anatomy really helps, is that you need to know what things are kind of occupying similar spaces, just in case one affects the other, or in case there's one problem that affects all of them. This was kind of a great way where, based on the way the levels looked, and we can go over that sometime if you'd like, because the brainstem is actually really easy to identify. It does not take long to figure out how to identify when you're in the midbrain, pons, or medulla. And if you know where you're at, then you know what cranial nuclei you should be seeing. And then if you know those, you know like where MLF will be, and some of these other things that are related to those nuclei. So the answer to your question, yes, but don't get too lost in the details. And don't study it just to memorize stuff. Always be thinking about what are they doing, where did it come from, where is it going to.
Okay.
That one in the bottom, 9, 10, 11, 12, that's medulla, right?
Yes, that's all medulla. 11 has an asterisk because it kind of comes from the upper cervicals, and so sometimes they call it the spinal nucleus, or spinal nerve of spinal accessory nerve, because it comes from the upper spinal cord, but also some of it comes from the medulla. But it's a weird one. It enters the skull and then leaves the skull out of different framing, so that one gets an asterisk because it's just moving muscles of the neck. It seems like a weird cranial nerve, actually, but it's technically cranial nerve 11. Yes?
And then just for the secondary motor neurons, are you saying that for the body and the face, it's the same?
Oh, keep those separate. That's somatosensory.
Okay.
Upper motor neurons have to be motor pathway. So this is for corticospinal, mainly. And this is for DCML, spinal thalamic, those two. That's actually a question I ask to mix people up all the time, because it does challenge your organization. That I would say, I would ask about an upper motor neuron lesion and put in somatosensory. Upper motor neuron lesion is different, right? That's going to has to be a motor injury. Does that make sense? So the secondary neuron in the motor pathway, don't confuse that with the secondary neuron in those sensory pathways. Only the somatosensory needs a 3-neuron chain. Motor, the corticospinal is only 2 neurons. The auditory pathway is like 12. They're always mixing and matching both sides. Auditory doesn't With auditory pathway, I just knew the different players, but I didn't learn the wiring, because the wiring, it's just all bilateral. It's very complex. And there's no really lesion questions, because the lesion question could be somewhere up in the brain or in the ear itself, but not so much in the connections in between, because they all have bilateral innervation. So if you affect one, it doesn't matter, it's gonna bypass it. So those are the things that, that'll save you some time studying. But ask Dr. E if he wants you to know a lot of details about auditory, but I would imagine it's very difficult to write a lesion pathway unless you're talking about the very beginning and the very end of the pathway. All right.
Thank you.
Thank you so much.
You got it.
Lifesaver.